Hello, here are the solutions for the normal distribution mock. Number 1, in her math IA, Patricia decides to show the number of times a student checks their phone during a 45-minute class as a normal distribution. In the space below, sketch this normal distribution with the mean 12 and standard deviation 5 that she found. Okay, so this is a really good thing to do. Even if I didn't ask you to draw it, it's a good thing to do. So let's get the pen. It's a good way to check your final answers to see if they make sense. So the mean is in the middle, that's 12. Standard deviation is the width of each one of these sections. So the next section label should be 12 plus 5, 17. The next one should be 17 plus 5, 22, and so on. So this would be 27. And then going down, it would be 12 minus 5 would be 7, and 7 minus 5, it would be 2. You notice that the next one is negative. We just ignore that because the way normal distributions work is sometimes they kind of go off the edge of the distribution, and we don't worry about it. Part B, another student says that the percent of students who access their phones less than 5 times would be at least 20%. 5 times at least 20%. So let's mark 5 on here. So 5 would be around here. And who access their phone less than 5 times would be these people here. And so another student thinks that that would be at least 20%. And Patricia says that it would not be at least 20%. And the reason why she knows is because of 68, 95, 99. So you're supposed to explain how she knows. So remember that 68, 95, 99 basically tells us that these middle two sections are each worth 34%. And then this section is worth 13.5, and this section is worth 2, and this is 13.5, and this is 2. So basically, this person says that this blue section is 20%, at least 20%. But you can see from 68, 95, 99 that basically this blue section would probably be part of the 13.5 plus 2 plus 0.5. So that would be maximum 16, right? It should be less than 16. So according to 68, 95, 99, the probability that x is less than 5 should be like less than or equal to 16%, right? Less than 16%, not even less than or equal to. It's less than 16%. So that's why, so it can't be 20%. Okay, so that's one way you can use 68, 95, 99 to verify or contradict some kind of claim, right? We didn't even need to put it in the calculator. We could already see that their claim was wrong. Part C, use your GDC to figure out exactly what percentage of students access 5 times or less. Then find the expected number of students who access 5 times or less if there are 30 students in the class. Okay, so now what we're going to do is we're actually going to use the calculator to figure out what this blue region is. And of course, if we know the numbers on the x-axis and we want to know the area, we are going to use norm distribution, CDF. So we're going to second distribution, and then we're going to go to normal CDF. The only two we ever use in this unit are normal CDF, which is number 2, and inverse normal, which is number 3. We never use number 1, okay? So basically the blue region is between negative infinity and 5. So we leave negative infinity, which is already programmed in there, negative 1e99, and we put in 5. And then we put in that the mean is 12, and we put that the standard deviation is 5. And then we paste. And the answer is 0.0808 8. If you like to write this in percentage, you would write 8.08%. Okay, so that's, I don't mind though if you just leave it as 0.0808. Even if it asks you for a percentage, I don't mind if you leave it as a decimal. Then find the expected number of students who access 5 times or less, if there are 30 students in the class. So then to find an expected number, all we need to do is we need to take the decimal value, 0.0808, and we multiply that times the given number of total students, which is 30, and that gives us 2.42. And IB always wants us to make a decision if that should be 2 or 3 students. So 5 times or less, I'm going to say that that's 2 students because 2.42 is a little bit closer to 2 students than it is to 3 students. So IB doesn't want you to put 4.42, okay? It wants you to put 2 or 3. All right, let's go to the next problem. Number 2, the GPAs in 11th grade at EAC have a mean of 2.5 and a standard deviation of 0.4. Draw a sketch of the normal distribution with these characteristics. So again, even if it doesn't ask you to draw the distribution, always a good thing to do. So the middle would be the mean of 2.5. And then the standard deviation is 0.4, so we just add 0.4, add 0.4, subtract 0.4, subtract 0.4. Okay. This will be 1.3. This will be 3.7. Okay. If we want to give an award to the top 5 students of the 42 total students, what would be the minimum GPA to receive the award? Okay, so top 5 students, that would be the people over here, right? And we don't know the GPA, so we don't know this X value here, but we would the minimum GPA to get in this elite group. But we do know this area here is related to 5 students among the 42 students. And the hint says, what is the percentage of 5 students out of 42? Then shade the percentage in the diagram. I've already shaded the diagram, but I want to translate 5 students out of 42 into a percentage. So it's 0.119, 11.9%. So I'm going to say that this is 11.9%, or I could say it's 0.119. And now I want to do is I want to find the X value. Remember, there's only 2 things we know how to do on the calculator with normal distribution. Option 2, normal CDF, and option 3, inverse norm. In the last problem, we knew the value that was on the x-axis, and we found the percentage or the area. This time we know the area, and now we're going to find the value on the x-axis. So what we're going to do is we're going to inverse norm in that case. And remember, if you have this old kind of calculator, this is a right region as opposed to a left region. It's not a left region. Since it's not a left region, we need to do an adjustment. We need to, instead of putting in the area 0.119, we need to put in the area 1 minus 0.119, because that would be the left region that corresponds to this blue right region. Okay, and you can actually put that in just by putting you could actually write 1 minus 0.119 in the field, and the calculator will do it for you. And then I'm going to put 2.5 for the mean, and then I'm going to put 0.4 for the standard deviation, and then I'm going to do paste. And it tells me that the GPA that corresponds to this X value is 2.97. And you can see that I drew it slightly in the wrong place. I should have drawn it a little bit farther to the left. Okay, so X was actually here instead of where I drew it. All right. Okay, so my answer for part B. Let's go to the next part, part C. For an annual report, EAC needs to calculate the first and the third quartiles for the 11th grade GPAs, find their values to 3 significant figures. So I'm going to redraw the distribution, and I'm just going to draw it to reflect quartiles. So for example, if I want it in quartiles, instead of 68, 95, 99, what I really want is I want 25%, 25%, 25%. And that kind of corresponds to our old friend, the box and whiskers plot, right? And so what we want to know is, we want to know Q1 and Q3, which would be this point and this point. And so the middle is 2.5, okay? And we want to know what is this value and what is this value, considering the distribution we have, mean 2.5, standard deviation 0.4. Since we know, like, let's say, okay, let's figure out the first quartile first. So this is like first quartile. Let's figure that out. We know that the left side region of the first quartile is going to be 25%. So let's do inverse normal, because if we have the area and we're trying to find the x value, we're going to use inverse normal. And we're going to put 0.25. And then we're going to put mean of 2.5 and standard deviation of 0.4. And that'll give us 2.23. That's our first quartile GPA. And then if we want to know this region here, we can see that the left region is 0.75. So we're just going to do second distribution inverse norm, and instead of 0.25, we're going to put 0.75, and this will give us the third quartile. We keep the mean and the standard deviation the same. And the answer is 2.77. So the third quartile is 2.77. And those are the two things we wanted to know. We wanted to know the third quartile and the first quartile GPAs. And I think that's it. Yeah, that's it.